A paleontology team lifts a skull from January 12, 2026, Coahuila, Mexico. A paleontology team from the National Autonomous University of Mexico, led by Dr. Maria Espinosa. They were excavating late Cretaceous rock formations. The Cerro del Pueblo formation, 70 to 73 million years old. The area had already yielded significant finds: tyrannosaur relatives, hadrosaurs, ceratopsians, but this discovery was different. The team excavated further, found more bones, vertebrae, leg bones, fragments of the pelvis. All confirmed this was a troodontid, but not one that had been described before. They named it Xenovenator espinosai. Xeno, strange, alien. Venator, hunter. Espinosai, honoring Dr. Espinosa. The Strange Hunter. Publication came fast. January 12, 2026. The team published their findings describing the first troodontid with evidence of headbutting combat. The paleontology community reacted immediately because this changed everything we thought we knew about raptor behavior. Troodontids were remarkable animals. Small, most species under 6 feet long, lightweight, 40 to 50 pounds, but extraordinarily sophisticated. Brain size relative to body mass among the highest of all dinosaurs. Intelligence comparable to modern corvids, ravens, crows. Large eyes, probably nocturnal or crepuscular, hunting at dawn and dusk when other predators were less active. Long legs, built for running. Estimates suggest speeds of 35 to 40 miles per hour. Grasping hands, 3 fingers, sharp claws, capable of manipulating prey, possibly using tools. And feathers, extensive feathers. Arms, covered with long, pugnacious feathers similar to modern birds. Body, covered with downy insulation. They looked like 6-foot roadrunners with grasping hands and raptor claws. For decades, paleontologists studied these animals, analyzed their skeletons, modeled their behavior. The consensus: ambush predators, intelligent hunters, using speed, stealth, and coordination to take down prey. Some evidence suggested pack hunting, multiple individuals working together. Combat between individuals, when it occurred, was assumed to involve claws, teeth, the sickle claw on the foot, slashing, biting, grappling, similar to modern birds of prey, eagles fighting over territory, using talons and beaks. But Xenovenator suggested something completely different. That thickened skull, 1.2 centimeters of solid bone, wasn't for hunting. It was for fighting each other. Thickened skulls in dinosaurs aren't unknown. Pachycephalosaurus, the most famous example, 26 feet long, weighed 900 pounds. Skull dome over 9 inches thick, solid bone, reinforced with internal struts. For decades, paleontologists debated function. Were they ramming heads, or just for display?
Recent studies confirmed they were ramming. Impact marks on the bone, healed fractures, evidence of repeated collisions.
Pachycephalosaurus used its dome like a battering ram. Males fighting for dominance, territory, breeding rights. The mechanics required specific adaptations. Strong neck muscles, anchored to enlarged vertebrae, reinforced spine, shock-absorbing joints between vertebrae, aligned body posture, head, neck, spine, hips in a straight line to transfer impact forces, modified bones in the skull base, thickened and fused to distribute stress. Without these adaptations, headbutting would cause catastrophic injury, broken necks, shattered skulls, brain damage. But with them, these animals could ram at full speed, absorb the impact, walk away.
Pachycephalosaurus had all these adaptations. And now paleontologists had to ask, did Xenovenator?
The team examined the fossils in detail. The skull dome, 1. Headbutting combat in animals serves specific functions. Males compete for territory, breeding rights, resources. The combat is ritualized. Rules evolved over millions of years. Both animals understand the boundaries.
Goal: establish dominance, not kill the opponent. Modern examples: bighorn sheep, musk oxen, giraffes, marine iguanas.
The fights can be brutal, but deaths are rare. The loser retreats. The winner claims the resource. This system works because both animals benefit from not escalating to lethal combat. Killing your opponent removes a potential ally, a future breeding competitor for others, a defender of the territory against outsiders. Better to establish hierarchy through ritualized combat. Save lethal force for actual threats. Xenovenator likely followed similar logic. The thick skull evolved as a weapon, but a weapon with rules. Males probably used headbutting to establish dominance hierarchies. Larger males with thicker skulls had advantages, could deliver harder impacts, withstand more punishment. Smaller males learned when to retreat, avoided serious injury. The system allowed Xenovenator populations to maintain social structures, establish territories, allocate breeding opportunities without slaughtering each other. But there's another possibility. Xenovenator was a troodontid, part of a lineage known for intelligence, problem-solving, possibly tool use. What if headbutting wasn't just about dominance? What if it was about communication? Some modern animals use ritualized combat as social bonding, establishing relationships, testing alliances. Giraffes engage in necking, swinging their necks and heads against each other. This isn't always aggressive. Sometimes it's playful, social. Could Xenovenator have used headbutting similarly? We don't know. The fossils can't tell us intent, only capability. But the thick skull opened possibilities. Social complexity beyond what we expect from dinosaurs. Xenovenator changes our understanding of troodontid evolution. Before this discovery, all troodontids appeared similar. Lightweight skulls, built for speed and agility, predatory lifestyles focused on hunting. Combat, when it occurred, used claws and teeth. But Xenovenator proves there was more diversity. At least one lineage evolved specialized headbutting adaptations, thickened skulls, reinforced neck musculature. This suggests selective pressure. Something in the environment or social structure made headbutting advantageous. Possibly high population density, competition for resources, complex social hierarchies, or environmental factors, open habitats where visual displays and ritualized combat were more effective than stealth and ambush. The Cerro del Pueblo formation, where Xenovenator was found, preserves a river system, floodplains, some forested areas, but also open ground. Different from the dense forests where other troodontids lived, open habitats favored different behaviors. Visual displays, ritualized combat, territorial defense. Xenovenator may have adapted to this environment, evolved headbutting as a solution to social competition. But here's the critical point. Xenovenator
Is the first troodontid with evidence of headbutting, but probably not the only one.
Paleontology has a sampling problem. We find a tiny fraction of species that existed, preserve an even smaller fraction. Xenovenator suggests there were other troodontids with specialized combat adaptations. Other species, not yet found. The discovery opens questions. How diverse were troodontids really? How many specialized forms existed?
We're only beginning to understand.
January 12, 2026, the announcement. Xenovenator Espinosa, the strange hunter, a 6-foot raptor with a thickened skull, built for headbutting combat, found in Mexico, preserved in 70-million-year-old sandstone, the first of its kind, the first troodontid with evidence of ritualized headbutting, but probably not the last. Somewhere in the rock formations of Asia, North America, or South America, there are other fossils, other troodontids, with specialized combat adaptations, waiting to be found. Xenovenator proves that raptor combat was more diverse than we imagined, that intelligence and agility didn't exclude ritualized violence, that small dinosaurs, built like birds, could evolve behaviors we associate with large herbivores. The fossils are housed at the National Autonomous University of Mexico, available for study, already generating new research questions. How common was headbutting among troodontids? Did other lineages evolve similar adaptations independently? What drove the evolution of thick skulls in small predators? The answers are waiting in museum collections, in the field, in rocks not yet excavated. Xenovenator is the first, but the story is just beginning. What other weird combat adaptations do you think we'll find in raptors? Drop your wildest prediction below. I'm reading all of them.